it's so amazing that you can pull in data from anywhere. Like I said, in the Jamstack, it's just typically Jamstack. You can pull in data from WordPress, um, Contentful, sheet of paper, if you can, and basically anywhere, right? And then it offers you flexibility of working with React components. So if you know how to build with React, you can build in like your React components in Gatsby. You could build like your layout with React. And do not be afraid. Maybe you think if you do not know React, you're finished. There's hope for you. You don't need to know React. Personally, I do not know React. But then I started, why are you smiling? I don't know React. Well, I started writing React. I started learning React with Gatsby. So people actually learn React with Gatsby, right? And then Gatsby offers you like everything. It gives you like crazy UI, mad-ass typography. You can implement like really awesome stuff when it comes to UIs and typography. And the best part of it is it comes with all these things. Like it comes shipped with all these things, so you don't have to like install anything, right? When it comes to media and handling, in as much as you can put in other media extensions, you can put in tools to help you optimize or serve your media. It comes shipped with media handling and optimization tools in it. Okay, there's still more. Sorry. So there's full-on flexibility with plugins. So let's say, for instance, Chooks here, he has a Gatsby application, or he builds this Gatsby application, and then the senior man over there decides that, oh, hey, I think I'd want to use this, but then I want to make it better, or I'd want to add one more feature to it. He could just build a plugin for whatever he wants, right? It's that extensible. It offers you that much flexibility to build in or adding more functionalities as you go, right? And then there's free performance for life. You don't get to worry about your site hanging, or it's been slowing down, or you losing customers due to speed. There's sweet cheap, my God. There's sweet cheap deployment with the CDN. You notice that you pay for actual servers, you pay a lot. But for something like Heroku, you could even use the free version. I used the free version for for a very long time. On Netlify, you use like free version of the deployment package. You use it for like, I'm sure some of you here don't even know you pay on Netlify or you pay on Heroku. I'm just kidding. Yeah, so it's even faster during the development, because basically with React, there's this hot reloading feature. But this time around, you're not even hot reloading only the content. You're hot reloading both the code. And it's crazy that you might want to catch the browser while it's reloading. Trust me, you won't. As you're pressing Ctrl S, it's refreshing automatically. So how do you start the Gatsby application? Just 4 lines. Just 4 lines to rule all. That's what I choose to call it. First of all, you install. Can you all see the screenshots there? Yeah, so first of all, you install Gatsby, and then you run the Gatsby command to generate a new site. So it gives you a starter. Gatsby ships with what we call starters. These starters are like preset websites. So it assumes that you do not have time. You don't want to stress yourself to build out something new. It gives you a website, like clean website. All you need to do is just pass in whatever data you want, edit the UI, and then those guys that build websites in few minutes or hours. You have the opportunity now. You have the opportunity now, right? And then you can run the third command, Gatsby develop, to just start a development server very fast. And like I said, with the development server, as you're making changes, you're seeing the changes in real time, as I choose to call it. The Gatsby build command builds an optimized site. And when I say optimized, it comes with like everything you've put in. It gives you an optimized static site you can deploy on the spot, right? If you have a Netlify account, you can just send it there, and then you could show it to your client like, hey, this is your website in a couple of minutes. So like I said, Gatsby uses plugins to extend functionalities. And these plugins come in like various types. Like I said, Chooks can build one, Prosper can just build any plugin, and he gives it to you. The major file where you put this is, if you look through the Gatsby file you built, you're going to see a Gatsby config.js file. So that's where you put in what we call the plugins, right? These plugins help you extend the functionality of JavaScript. If you look at these plugins here, you see plugin Sharp and plugin Transformer Sharp. It helps you transform image, optimize images, right? You're seeing the plugin Glamour, that's for typography and UI. You're seeing the plugin Offline. So you'd want to build a progressive web app. You don't have to go through the stress of building one thing, writing manifest files and all that, right? By simply putting in this plugin here, just Gatsby plugin offline, you have like an offline application. You have a PWA. See how easy life is. Yeah, so here's Google Analytics. You could just throw in Google Analytics, pass in your tracking ID, and then you have analytics shipped in. Same thing with so many other features, right? Life is just easy, man. Yeah, so I built a site like over the weekend. And I decided to test it. Here's like the mobile. Oh, no, I didn't build this, please. It's not what that's reactjs.org. That's reactjs.org, right? So I decided to test it because React.js is built with Gatsby. And this was like the result I got. You can see how super fast it is. Optimization 99 over 100. Yeah, and then I decided to test like a desktop site. I used the Gatsby.js sites themselves. You can see like the scores. That's like amazing. That's really crazy scores. If you use Lighthouse, just go to audit. This is actually Chrome Dev too. Just go to the audit tab, start a new audit on the site, and then you can pull out this report. So because of time, I'm going to be running through like what I call the steroids, right? Basically, these are the things that make Gatsby tick, or that made those scores pop up the way they are, or make them really crazy, right? So like I said, in production, Gatsby gives you static content, which you could just deploy to CDN. It ships like as a full progressive web app. The images are optimized. The images are also responsive. So those are two different things, right? While the images are optimized, you know we have different devices. You'd have to like, you don't have to edit or, what I say, manipulate your images for each different device. You could just ship one image and then it optimizes for different devices. And when I say optimize, it doesn't ship. When you use services like Cloudinary, right? They help you with, you know, techniques like blurring out images, reducing the size, lazy loading. Gatsby ships with like most of those things. But that doesn't mean you could not use other services like dedicated, like I said, dedicated plugins or dedicated services that help you with these things. You could actually implement them. In development, there's a hot reloading feature, not just for the content, but also for the code. Another crazy thing is Gatsby uses GraphQL, right? So the data is actually very, like, it's mad fast. With React, you get the component architecture for development, still on steroids. You can write Gatsby in production, right? All critical CSS, right? What is required to load that initial page that can slow your life down. Gatsby will actually write that CSS inline to make sure that everything ships like really, really fast. And then it's purely serverless. So you know there's a difference between serverless and serverless. So serverless, some serverless, you have to write the actual servers you keep somewhere. But then with this, there is no server. It's just on Netlify, except your friend built something for you, right? And the dev experience too is it's really awesome, right? In development, you use modern JS syntax, ES6, ES 2017, whichever one you're familiar with. And if you're not sure of what you're writing in, there's Babel and Webpack to help you, you know, compile and manage your assets properly. Like I said, there are starters to help you, like, get you going, right? If you want to build a blog, there's a starter for blogs. You want to build like a website, there's a starter for website. You want to build a fashion site, your friend can help you build a starter for that as well. Yeah, so just because of time, I'll just take questions. I'll take questions now before we kind of like move on. Does anyone have any question?
With Gatsby, can you have forms?
Can you have what?
forms, like fill forms, send forms to the back end.
Send forms to the
Yeah,
back end.
yeah, like yeah.
Yeah, like I said, it uses React,
Okay.
right? So whatever you can build in interactivity to it, right? All you just need to do is have like plugins that can accept those form fields and then send them over and like to an API, right? That's fine.
Any questions?
Any other question? Who is not clear? Here's your time to ask me or forever hold your
I mean, I expected a lot of questions for this session.
I have t-shirts to give out for questions.
I have a question. I have a question. I have a question. So we've been talking about Gatsby and like all the awesome things that Gatsby can do. I mean, we're used to building stuff with React, Angular, Vue.js, and Aurelia, and so many other types of frameworks. So is Gatsby a framework? Is Gatsby a tool, just a tool for building sites? And can I use Gatsby to build a social network? That's a valid question.
Okay, so I think your answer should be, is your social network going to be a static site? If you'd want it to be a static site, then. But then, I mean, your Prosper, you can always extend your application to.
Another question. I'm sorry I'm taking your time. So, you said Gatsby uses GraphQL, right? Now, when you talk about the plugins that Gatsby has, the repository of plugins, right now, do you have like a plugin? Do you have a plugin for Apollo?
Apollo.
Yes.
I'll have to find that out. There's like over 300 plugins currently. And I don't know, you can memorize all of them, but I can't. So I'll have to find that and then I'll just let you know if it does.
Right. Thank you. Thank you. Any other question? Okay, Innocent.
So I got a bit excited when you said, right? But this question now gave birth to my question.
I'm scared. Though.
If it's just for static sites, if I want to build a static site, right? I just play everything I'm playing in dev and then minify the life, right? Uglify the life, manify it, just reduce it to the barest minimum. But now there's Gatsby. Where does it come in and how does it help me with what I already know I can do?
Okay. So like I said, right? Gatsby ships with, you said you minify, you uglify. How do you handle your images? You uglify your images? Your images. How do you handle the images on your site? Yeah, so Gatsby just makes your life easy.
So I think if I rephrase this question, like in the scheme of things, right? In the scheme of things, where does Gatsby fall in with all the knowledge of all the frameworks and the fact that you can minify and uglify everything, and then you can, yes, you can actually, make your site fast with Webpack. Webpack 4 does a great job at that. Okay. So with all of this knowledge, like where does Gatsby come in that makes my life really easy?
Okay, yeah. So when you're building out projects, right, you have to think about quality, cost, and time. Right? Now I'm talking about time here. Gatsby saves you on these three things. You spend time on quality, using Webpack, using Babel, uglifying things. You spend minutes on implementing things. But then Gatsby ships with all of these things. You just have to configure them. And we're moving to a state whereby you do not even have to configure these things anymore. So it just helps. It just makes your life easy. But if you say you want to go the longer route of doing the long job, I mean, you're a senior man. You can. Thank you very much.
All right. Hello, house. My name is Toby. My first of many questions. First of all, what's the opposite of a static site? We're saying static site, and he can't build social network with Gatsby. So first of all, what's the opposite of a static site?
Yeah. So basically, a static site is a site that is served as it is on a CDN. Right? There's no client-server interaction. So the opposite of a static site is a dynamic site. A dynamic site whereby you send requests to a server returns a response, you keep going back and forth and back and forth. That's the opposite of a static
All
site.
right. One thing that is a fear to many people delving into React. You said Gatsby like is a Reactish something. So one thing that is a fear delving into React-based stuff is configuring Webpack. All right. So do I need to have a knowledge of configuring Webpack to be able to really make sense out of Gatsby?
See my hand. Zero knowledge.
Thank you, Achilo. Thank you, Williams. That was a great session.
Thank you very much, guys.
So there are still more questions for you at Chulo, but then I think they can come and meet you individually. And then you can statically give them the answer. All right, so our next speaker is someone we all know. And I think I need to introduce him specially because I've known him for a while. We've been brothers for over like 3 years now. And we virtually do the same thing. It's just that he's short and he's tall and I'm short. That's a very clear difference. And his name is Christian. We all know Christian, otherwise known as Code Beast. And one very significant thing about him is that he has refused to change his avatar since 2016 on Twitter. And then it's so funny when he prints out documents to submit to the embassy, it's the same avatar. I don't know, maybe that's why, but Christian is a developer advocate. He loves the community so much. He organizes so many things. Like he co-organizes FrontStack.io. He's one of the board of trustees for 4Loop Africa. I mean, for so many of the countries where we've birthed 4Loop, it was both of us that, were in these countries together. He's very selfless. He's a developer advocate at Cloudinary. He's also a program manager at Scotch.io. I don't know, he works for so many organizations. He does a lot of things. Like, I can't finish saying all the things he does because he's just a very awesome individual. And then he has helped, he's one of the core members of the team that put this together. So he's going to be speaking about GraphQL versus REST. I mean, just few intro, just like 2 seconds intro about that. REST is the way we have been developing APIs before now. GraphQL was released by Facebook. And then right now, there's been a serious heated argument about which one is better. Is it REST? Is it GraphQL? And I think Christian's talk is just going to quell all the answers, all the questions we've had concerning these 2 technologies. So take it away, Christian.
Hi everyone. Okay, let's get settled so we can talk about this guy called GraphQL. Okay? So I always ask for a favor before my talk. 2 favors actually. The first one is that give me a round of applause. It's so hard to come to this stage, so please. Thank you. And the second one is, even if I don't remind you, please just be nodding your head. It gives me encouragement like I'm making progress. Okay? Yeah, thank you. So, and GraphQL versus REST. In my own opinion, the best way to talk about a new engineering tool is to compare it with its successor. Okay? Which at this point we're comparing GraphQL and REST. So, generally, we're going to cover the following. We're going to have a recap on server-to-server networking. Like, it's something we basically know, but I'll just show you a diagram on how things work so you can refresh your memory. And then we're going to compare SOAP, REST, and then this new girl called GraphQL. We're also going to consider why REST is not the best networking standard. Okay, I know it's something we are very used to, but we're going to talk about why it's not the best networking standard so far. Lastly, we're going to discuss the fundamentals of GraphQL. I'm not sure if you can see some code examples because the time is so short, but I plan to show some code examples if we have enough time. So at the end of this talk, instead of treating GraphQL like this, at the end of this talk, instead of treating GraphQL like those cards, like the way they are curious, trying to find out what this is how we basically relate with new. These are relationship with new frameworks. Okay, so instead of treating GraphQL as like those cats, we're going to leave the hall like those ladies. Yeah. So hopefully now that I've gotten you excited about GraphQL, let me introduce myself quickly.
Still the same avatar.
Yeah, so I'm the guy with the same avatar, and my name is Christian Code Beast Mwamba. So I'm officially taking that name as my middle name. And I'm a developer advocate at Cloudinary. I'm co-organizer of ConcatenateConf. I also help organize For Loop Africa with Prosper and other organizers. And I'm also a front stack co-organizer with Ire. I'm also an author, yes, I wrote 2 books, yeah. Thank you. So, like most engineering solutions, the best way to understand the problem they're trying to solve is to look at the existing issues that we had previously. Okay, so we are going to actually like have a recap, take a look at history, and look at how server-to-server networking work fundamentally. Basically, you have a client, and when you hear the word client, it doesn't have to be like a laptop. A client can be a server as well, right? So you guys can nod your head so you can encourage me. Yeah. It can be a server, it can be a laptop, it can be a phone, and then this client makes a request to a server. Okay, the server processes the request, probably does some data and storage, and then it responds with a response. Okay. This is just a blueprint. It doesn't show you how anything works. It just defines what the picture I show you doesn't make a request. It doesn't respond with any response. So how is the actual process completed? Does anyone remember SOAP? SOAP. Yeah. I know we are 90 kids, so we won't actually like know what it is, but SOAP stands for Simple Object Access Protocol, and the simple in the definition is a very big lie. Yeah, like it's the biggest lie I've ever heard. And it's based on XML. For the Android developers here, you guys know how heavy XML is, okay? Yeah, it's really heavy. So compared with this other guy called REST, does anyone know REST here? Yeah, I told you are 90 kids. So REST is very gentle on the brain. Okay? It's lightweight. It's JSON. So it's very, very lightweight. It's descriptive. You can easily tell that we have a table here with 2 rows. Right? And it uses verbs to like describe requests. So when you hear things like get or post, it's really descriptive to tell you that get is fetching a request and post is making a request to a server. So in that case, why not just REST? Okay? Yeah, so from now on to the end of this slide, I'm basically going to be telling you why you should not be resting. Yeah. So there's an issue called underfetching versus overfetching content. So let's have a look at this illustration. Let me paint a picture for you. Assuming I have this client, okay, that's making a request for a user. So I have a request. I have like a //user/ID. So it makes a request to a server, okay. Then the server processes this request and returns a JSON payload, right? And then that JSON payload is sent back to the client. What if I actually need that user's post, not just the user? The server tries to make, the client tries to make a different request, okay, to the same endpoint. And let's assume that endpoint was now designed to return a user's post. If you noticed, the first question we would have asked is, why we probably have two endpoints. You have one making for the user and we have one making for the user's post. Why not just have one route that fetches the user details and includes all the posts that were submitted by the user? But then there's an issue. If we include the posts as part of the response, and the client doesn't render those posts, assuming they're just creating a profile page where you just have the username and the name and the email, what we call overfetching occurs. Okay? So we'll have an array of posts that ends up being useless to the client. Am I painting a picture? Just nod your head. Yes. And at the end of the day, you have a negative impact on your application because you're basically fetching a lot of data you're at the end of the day you're not making use of. Okay? But then if we now decide to go the other route and just fetch what we are doing already, we just fetch the user differently and have but then fetch the user differently, and then if the post is needed, we get the post. But then what if I fetch that user? The client doesn't have, you have to like define specifically that you need the user or that you need the post. Okay, so if we fetch just the user's information without the payload, and then at the end of the day, the client needs the payload, another request is made. So we'll have something called underfetching happening. So you're making a second trip to the network to fetch that resource, to fetch a resource twice, which you have fetched the first time. But then you fetch the first time and it's not needed, overfetching occurs. So like you have like a bit of a big issue that you can't actually like easily escape from. So I had this slide, this particular page, and I asked Sarah Drasner to help me to review the slide, and she said that she'd tell you guys that if there's anything you take away from this talk, it should be this. When you're designing an API, you shouldn't design an API. It's best, in my opinion, and probably in another person's opinion, that you design. Sorry, Rotimi is trying to get me another avatar. That's why he's standing here. so it's best you give the client what it needs. Don't give the client what you think the client needs. So when you're designing API, basically, let's say I'm designing a blog API. I have a post endpoint, a user's endpoint, and stuff like that. And in the user/ID, just give me the user information. Don't try to like include the post because you think, oh, maybe at the end of the day, the client might need to render those posts as well. Okay, but then it's not as easy as it sounds to like have a single endpoint for just a single resource. So I'm basically saying if I need an email, if I need a user ID and the user's post, don't give me the user's email, don't give me the user's name. Just give me that ID and the user's post that I asked for. I'm basically asking you just, how can I ask a server to just give me a particular information from the database without requesting every other data that is not needed? There are even more problems apart from underfetching and overfetching. We have the issue with schemalessness. REST as a means is too flexible. Okay, so validation is hard. The only thing you rely on to tell you how the structure looks like is documentation, right? You just have documentation that says that the user resource has name and email and stuff. And things can break. The developer can just wake up when they remove the email, and the documentation still says that the email is there. So it's actually very hard to like have validation going on. So it's just so much flexibility for building systems. And as I already mentioned, APIs are so reliable for things like this, and API documentations are so reliable. On the other hand, we have prototyping friction. REST as a protocol now is too inflexible. Okay, I have /users /ID/post, and then someone wakes up tomorrow and a user wakes up tomorrow and then we have a new user story. The whole idea changes. the UI, just a change on the UI has a high chance to affect the structure of your API. Okay, it's something we normally encounter in our workplaces. Structure generally, it's just difficult to like keep a good it's difficult to have a rigid structure when prototyping, and then at some point you need something more flexible that you can just ask for what you need from the server, and then the server gives you what you need. So what if we had a type system? The way in C# you have classes, interfaces, and stuff like that. What if we had something like that for REST? Okay, like a type system, not just for the language, but for the standard, for the protocol, for making a request. And what if you just had one URL endpoint? Like, why do we have to like have at a page you have a full list of documentation with a lot of URL you have to memorize as the front-end developer? What if you just had one endpoint and then a data structure, a type structure? And all if you just had that one endpoint, what if we could make all queries and all mutation directly from that endpoint? It sounds impossible, but what if we can do that? And what if we had a way to self-document our APIs? Like after building a new feature, we don't have to write a new documentation for it. It self-documents itself. So say hello to GraphQL. So we're going to go through the GraphQL fundamentals, and that's all. GraphQL uses a language called SDL. That's the only way you can have this type, and the type language I was talking about. What if we could have a type system for GraphQL? So we have SDL, which is this mic. We have SDL, which is the language for GraphQL. It's basically the language for GraphQL. And it's a type system. It serves as a contract between the server and the client. So whatever the server defines as the type, if the client doesn't adhere to those instructions, an error is thrown. So if SDL is the language for the type system, what does the type look like? This is exactly what a GraphQL type looks like. So you have something like an interface, like a structured programming language interface, where we have an identifier. Okay. You have the name of the type. In this case, it's called to do. We have the fields. We have an ID, a task, and a created fields. Just like the way you have properties in objects, those are what fields are for. Then we have the field type. So you can see types in play. The type itself is typed, and the type's fields are typed as well. So the ID is a type called ID. The task is of string type, and the created field is a datetime type. And then we also have this question mark that says that particular field has to be non-nullable, so it can be empty. And then we have directives. So the directives are GraphQL specifications that allow you to extend the existing type. So we're basically saying that this particular field should be unique. There are other types, apart from what you've seen. We have three major categories: the scalar types, the custom types, and the other base types. So the scalar types are these primitive types that you know from other languages, where you have integer, string, float, datetime, and boolean. The custom types are the one you create for yourselves. So like in structured languages, you have C#, you have classes, and those class names, in this case, or interfaces, those interface names are the custom types in GraphQL. So just like the to-do we created in the previous slide, in this case, it's a custom type. A custom type can be a resource in your application. So there is to-do, there is user, there is post, there is cart, there is animals. It can be anything. Then other base types, which are GraphQL defined, are things like interface, enum, mutation, and query. And you're going to see the differences between those base types now. So these are what custom types look like. You've seen them previously. We have a person types with different fields. We have a comment type with different fields. And you can see we are building a relationship here. The comment, the person can own multiple comments, and a comment can be owned by one person. Okay, so you can actually define relationship in your SDL, in your schema definition language. I spoke to you about base types, which I mentioned query and mutation. So this is what a query looks like. You cannot directly interact with your types. So I can't directly ask for the users. I can't ask the users types to give me the list of users. I have to define a query, which at the end of the day looks like what you have when you have an express callback. Do you guys who uses express here? Yeah, you know what an express. I'm trying to. If you've made a request, if you've like processed a request on a server, there's always a function that handles that request. Okay, so the query defines a type, and that type at the end is translated into a resolver. So at the end of the day, I'm going to have this task be a function that's going to return an array of tasks. Okay, and then this is what it's going to end up looking like. The normal JSON you need, but at the end of the day, you can just define what you need from. You don't have to list all the values of to do. You can just ask him for the task value or the name or the ID. Okay, you can see we're not overfetching right now from what you have on the screen. Then there is another type called mutation. When query serves for reading values from the server, the mutation serves for writing values to the database. So you can have a mutation called add to do. When the mutation occurs, it creates a new value in your database and then returns a response, just like the usual REST endpoints that we'll have. I was supposed to have a demo. For 4 minutes. I can't. I'm not sure I can. So I was supposed to have a demo, so I have to like show you guys how to set up a GraphQL server and stuff like. But then we end up having just 5 minutes for the talk. So instead of taking the demo, feel free to ask me questions. It doesn't have to be what I spoke to about at the talk, but relating to GraphQL. So we can use the next 7 minutes to answer them.
Are you done with your presentation?
Yeah.
All right, questions, please. Okay.
Amazing, crispy, clear presentation, Codebeast.
Yeah,
Great
thank
work. Straight. I want to get up and running really quickly. Prototype an idea, get it out. Prototype an idea, get it out. At the same time, knowing that once this hits, I want to leave it for developers within my ecosystem to work with quickly and manage. If you're in those shoes, what would you do? REST or GraphQL?
Did you get this question? I'm not sure I heard it clearly.
Okay, so the question, basically, REST is very unknown. REST to speed. GraphQL has this learning curve and this boilerplate code that you have to work within client and server. Get up and running really quickly, really fast. What would you use?
Did you ever write SOAP? Did you ever write SOAP? When you wanted to learn REST, was the learning curve smooth? Yeah. Yeah, so it's just a general problem with new technologies. There's no quick and way out of. The only thing that's actually been so fast for me to like move with is Vue. That's the only framework I've used that I was so fast to get started with. But my advice is this: GraphQL doesn't take away REST completely. Okay, so start prototyping. Just start with what works for you, and then you can mix and match. You can have both of them work on the same system. Yeah.
Okay, so great talk, by the way. I just have a few questions. Is GraphQL really different from REST? Because, for example, now, since GraphQL provides tooling that makes development easy, like the GraphQL, and you inspect the dev tools, what you end up seeing is not so much different from if you're making an actual REST request. So is it that it's different, or it's just REST on steroids?
Yeah, I think that's the best way to put it. When people hear REST, we pay so much attention to things like HTTP verbs, things like get, post, put, and stuff like that. Okay, when I say REST versus GraphQL, I mean GraphQL versus get, post, put, delete. So at the base of GraphQL, it just uses HTTP requests. You understand? And then it returns JSON, which is basically what you do with REST. But then the way the protocol just changes. It's not different technologies.
Sorry, can I answer that question too?
Yes.
All right, so I think the advantage of GraphQL over REST, I mean, it has its own disadvantages too. But then the good thing is that when you have to request for some resources via REST, and you have to do, for example, you need to get the details of tweets of a user. You say /user/ID/tweets, right? And then when you get the information of the tweets, it also like returns a lot of information. And then you now have to use your JavaScript functions to actually scrape out what you need from the JSON response, right? When you're using GraphQL, you can just specify it from the query that this is exactly what I need. So when you make a request to the server, it doesn't return all the information that you do not need yet. That's one advantage. Then another advantage is that when you're doing, what do you call it? Sorry, just give me some time. Okay, I've forgotten what I wanted to say. When you're working with GraphQL, you have fantastic tooling. And when you're talking about fantastic tooling, an example is Apollo, all right? You have the Apollo client, you have the Apollo server, so it's very easy for you to come up with a GraphQL server with Apollo. Then also, the same way you have Google Analytics and Sentry for your developer applications to track what happens on the front end or what goes wrong, you have Apollo Engine. Apollo Engine can help you track the performance of your queries. So for every part of your website, why are you guys laughing? I am spreading knowledge, guys. All right, next question.
Hi. So you said that when you are using GraphQL, you only use one route, right? And then as developers, we know that some routes have, for example, authentication. So how do you handle a case where a route does not require authentication?
Yes. Let me. I understand your question. Okay. I'm just trying to rush so we can get as much question before it's 11:30. So those route-specific implementation are not done on the route. They are done at the function level. They're done at the query or mutation level. They're done at the resolver level. Okay, so what the stuff I showed you had a query and a mutation. When a request is made, it gets to the server, fine. Okay? Remember, when you're protecting a route, you're actually not protecting a route in REST. You're protecting a resource from your code. I don't know, just get this picture. There's nothing like, okay, I define this endpoint, and then if you get here, you go back, if you're not authenticated. Rather, you have a function in your app, right? In your express function, you have, if this user doesn't exist, return a 401. That same function is what returns a 401 in there are resolvers, and they return 401s if the user is not authenticated. So it's at the resolver level, not at the route level. Does that make sense? Have you used GraphQL before? Okay, just know that there are functions that handle the queries you make at the server, and those functions are responsible for authenticating your request.
All right. My name is Fred. I think GraphQL is really awesome. I've not actually used it to build an application yet. But what I wanted to ask is, you said if you already have, like he mentioned, you have an idea and you want to roll out an MVP real quick, which one do you go for? Say you are more familiar with REST, so you use REST. So at what point do you consider switching or at what point do you start introducing GraphQL into your already existing application?
When I said you should switch, when I said you should use REST if you need to like prototype quickly, it doesn't mean that if you understand how GraphQL works, if you've learned GraphQL and understand how GraphQL works, I will always, like, even when I'm building an app, that if I used REST, it would just be one endpoint. Concatenate registration page was GraphQL. I still go with it so I can get more familiar with it and prepare myself for future bigger projects. Okay, so don't spoil yourself. Don't stick with REST because you're more comfortable with REST. Get out of your comfort zone and try. And
I think I have an answer for that.
okay, we are not going to allow Prosper to answer.
I'm not going to talk too much.
No.
I'm just going to give you straight.
No,
all right?
okay.
So at the point where you're thinking of incorporating GraphQL into your product architecture is when you're looking at moving or iterate very, very fast between your product teams. So you have your backend engineers normally, right? Building your API services. Then you have the front-end developers. Now, these two guys think differently. These guys are building the microservices. These guys are building the stuff that consuming those REST resources, right? And one thing you discover about REST is that when a new feature comes up, you have to wait and depend on the backend engineers to create a new function or create a new resource for the front-end developer to what? To now come and consume. But if you're using GraphQL, that scrapes all of that. If you're using GraphQL, all of you guys are moving together because before you even move, you guys look at the schema. You have a schema that is binding the client and the server, and you agree on a contract that this is what our schema is going to look like. Whether it is backend or frontend, it works both ways. So two of you already are aware. So as you're adding a new feature, you're just what? You're changing the schema. And once you're changing the schema, the only other thing that you need to do is just to add a resolver function and you're done. And then you guys are moving fast. Any questions?
Yeah, just one last question. Yeah. Yeah, just give him.
Just, okay.
Thanks. Thank you for your talk.
Yeah.
So I feel like one of the biggest advantages for REST was that there were standards. So if I was making a get put post request, there are things I'd expect. And so browsers could be optimized to handle certain responses from the server without even the client page seeing or dealing with that. I am wondering how that is handled with GraphQL.
So GraphQL at this point just works with one, which is post.
So then how can we optimize for setting, for example, status codes are very important.
I think I have answered to that.
No, Prosper is not. No, I'm the speaker and Prosper is not answering. There's no more time. Yes. Yeah? So you said, let me get your question. The second thing you said.
How do you undo status codes in GraphQL?
So as I mentioned, the why GraphQL is really difficult for people is that they're picturing the way REST works as where you have a property, a table where you define an endpoint and define properties to that endpoint. You remember all those things you define them at function level. If it's a 401, if it's a 200, you do like a request or status or response or status 200 is equal to 200. I don't know if you remember. So if the response was successful, it returns that status, and then with a payload, which that payload does not just include it in a small box. Okay, so that enforcement is not strict to the web is free. Should be you are writing HTML and JavaScript differently. Now you're writing HTML and JavaScript. The standard was write them differently. You understand? So that standard is not, it can be broken, and then you can have like better ways of doing things. There's an improvement. Yep. Okay.
I think one way that you can just optimize for that, if you really want to get that functionality back, when you're getting your GraphQL responses, it just gives you the error. So now, if you built your server using something like Apollo server, it comes, the latest Apollo server 2.0 comes with what you call different types of error classes. That for each error classes, you have the forbidden error, you have authentication error, you have the different types of error that you can enforce So that when the GraphQL responses come back, since by default you don't have a status code apart from 200, you can now specify that this is the type of what? Status response that it should return with the status code. Okay, so when you look for the Python implementation, which is Lysine, it's not Lysine that you guys use in Python for the GraphQL. Graphene, right? I don't know for the implementation of Graphene, but I think you can also submit a PR as a spec that can go into Graphene and then into other functionality. Then concerning the authentication aspect, I have a speaker deck. Just search for Unicode developer, authentication and authorization in GraphQL. You see the answers to that question there. 4 ways of doing authentication, 3 within GraphQL and 1 outside of GraphQL. So just search for it, you see the response to it there. Thank you. So our next speaker. Thank you, Kristen. I know we've taken a lot of time. Thank you for that great presentation. So our next speaker is Colin. Colin works for Cloudinary, and Colin is a very known name in the performance world. It deals a lot with performance and images and lazy loading of like media assets and all of that. In fact, he wrote a very big book about how to handle images, different types of images, from JPG to PNG to SVG, the performance, like how to optimize and transform images, all these things that you take for granted when you're developing web applications. You actually see how your images are processed from the first time your website loads the image to the time it is downloaded on the client, which can be the users, can be the websites that the user is using on the Android platform or on iOS or a mobile app and all of that. So, is Collins ready? Thank you, Collins. So,
hi.
Take it away.
Awesome. Can you hear me well? Audio working?
Yeah.
Excellent, excellent. Thank you for that great introduction. So today I want to talk about service workers. Now, can I see I don't know if I can see anybody. Can I see anybody work with service workers before? Yeah. So I feel like it was a little bit of another service worker talk. So I wanted to do a little bit of a pivot and focus on some of the interesting ways that we can use service workers to enhance images and video. So I talk about it as for the little guy. As was mentioned, I'm Colin. I'm from the CTO office at Cloudinary. I wrote a little book about high performance images, and unfortunately, I wasn't able to join you today. Although I did try to make some of the logistics work out. So I hail from Ottawa, Canada, a little place a little further away from you, but it's a beautiful day here. The sun's just starting to come up, so unfortunately I wasn't able to enjoy your beautiful country. So I thought I'd share a little bit of my some pictures from around here. Now you're probably thinking, wait, I know Canada. That is not Canada. Canada is winter. So obligatory, yes, there's a lot of winter, and sometimes my front yard looks like this, with a little bit of extra snow in my front yard. But before we get going, there's 3 things I want to talk to you today about. One is WebPerf. I would be amiss if I didn't talk to you about why it's important to talk about performance. And as we talk about that, I want to talk a little bit about service workers. Service workers are great, and we're going to cover just a little bit about the basics of this. And then finally, the meat of what we want to talk about, I want to show you some really clever ways that we can use service workers to improve performance and the media experience. If you want to put it in a different way, though, at the end of this, I'm hoping that you can walk away with something to impress your boss, something to impress your coworkers about some new knowledge that you have, and ultimately something to impress your mom, how you made the internet better, how you made the experiences that she has on a regular basis that much better in her life. So let's get to it. So let's talk about web performance. At the end of the day, your users just want to do basic things on the internet. They just want to upload the photos from last night or buy a birthday present for their mom. They want to check the news. But unfortunately, and I'm sure everybody in the audience has probably seen this yourself, the experience on the internet is not always the same. Sometimes, maybe a lot of the time, it's a lot slower than we experience. You may have, if you've spent time or heard people talk about web performance, you may have seen a graph like this. And this is a page load time graph. That is, if I took all the people that visited my site and stacked up all of their experiences, how long did it take to load a web page? I added them all up for each people that took 2 seconds, 4 seconds, 6 seconds. You'll get this little curve like this histogram. And from this, you can see where do most people experience the web. Now, there's been a few studies out there, notably Cliff Crocker, almost 10 years ago, kicked this off when he discovered that at Walmart, hey, performance, if I improve performance, my conversion rate, people that actually visited my site went up. I can improve my business by improving performance on a website. So that's one of the big takeaways that I want to make sure you leave with to impress your boss. And if you're needing statistics, there's a great website, WPOstats.com, that allows you to show, hey, why do I want to spend time rebuilding some parts of this web application? Why do I want to improve the web performance? Because it's going to make business better. You're going to improve the business's top line and improve the user experience at the same time. And why does this happen? Well, part of it has to do with the psychology of experience. There's a lot that goes on that we're easily distracted. Our lizard brain, if it's taking too long for a web page to load, then we're off thinking about something else. Or as we're going to check out, the bus comes and put my phone away. So there's a lot that goes on. And then unfortunately, I don't have time to talk about this. There's a lot of great research coming out these days about the psychology of decision. And there was just an article, I put it down here in the bottom, article that was on Hacker News just yesterday, more about the illusions that happen when the brain interacts. A lot of great stuff in there. And there's this magic number around 2 seconds. The number of studies have showed that between 1 and 2 seconds, you've got time to engage the user. After that, there's this quick drop-off of user engagement. People fall away, do other things. And often, as developers, we often think about everybody being just like us. Everybody's got the Samsung S8, and it's really fast. I'm at my office, and it's great. Why isn't the rest of the web experience just like mine? Well, the reason is that, there's a great diversity in users out there. And so when we're talking about how to improve the performance, a lot of it has to do with building some empathy. I just recently did a road trip with my family. This is what we Canadians do for vacation. We do a lot of driving. Very big country, not a lot of people. I think in Nigeria you have 5 to 6 times more people than in Canada. So we're very spread out. So we do a lot of driving. And while we were driving, my internet connection, I work at home. I get spoiled when I'm always at home on Ethernet and it works. But in the real world, I had 1 bar of signal and maybe 1,000 millisecond round trip time. It was painful. Tried visiting Disney's website about the new Incredibles, and it took a long time to load. And why is that? Well, if you look right down at the bottom, 29 megabytes. Thank you, Disney, for a very slow web page. 29 megabytes. But it looks nice. So what can we do about this? Well, like I said, we're just going to screen through this, but 3 quick takeaways to look great and, to your boss. 1, let's measure performance and find ways to empathize with your customers. As we look to empathize, we're looking to use other technology to help solve these tech challenges. So this is where service workers are going to be a big help. And ultimately, as we improve performance, we're going to help grow your business. So this is number 1, how you're going to look awesome to your boss. You're going to tell them, hey, improve performance on the site, I can drive more revenue. I can help get more users to adopt our site. So let's talk about service workers. Now, if only I could add a little bit of JavaScript that said, make my site faster. So add more JavaScript? It'll make my site faster? Yeah, I don't think anybody's ever said that in the history of time. It's an unfortunate state that JavaScript always takes the website and makes it slower. And part of that is, of course, that when we load JavaScript, we have to download the content, and the browser has to then evaluate it, and then execute it, and then run it on the page. And every time that you refresh a page, you have to do this all over and over again. So service workers, while they are JavaScript, are slightly different. Service workers are, you may, and for those that didn't put up your hand, this is a lot of really great technology. It's taken a number of years to really push through. And it fundamentally has changed a lot of the ways that we think about building a web app. And there's a number of big tenets around it to help us bridge the native app experience and the web experience. And the great part about it right now is that here we are in 2018, and we've got great support across the browser spectrum, that between Edge, Chrome, and even Safari, we've got great browser experiences that have service worker support. So service workers, what are they? Well, they allow us to run JavaScript in the background in a separate from your web page. And if you look at them, it's really simple. All I need to do, 1 line of JavaScript, I register my own JavaScript there. So the service worker is now registered, and that JavaScript can now do stuff even when the web page isn't there. If you look at the waterfall, you'll notice right down at the bottom, you'll see my service worker.js running. Great. You also notice how far away it's loaded after the page is loaded up. Now this is because the way that service workers are built, they're intended to interact with the page, but they intended not to block the page loading. So think of this service worker as this JavaScript that runs, and once it's loaded, it can interact with all of the requests coming through the site. So all of the fetch requests for JavaScript, CSS, images, all of those get pushed, get the opportunity to go through service worker, and service worker can then decide, do I want to go somewhere else? Or more often the case, you probably will see, it goes and says, hey, I can put stuff in the cache. And this is important for when you're taking your web page and trying to make it more like an app. Could I give you an offline experience? Can I download all of the parts of my web page, all the images, the CSS, and kind of keep them locally so that I can make it available when the user is in an offline environment or when they don't have internet requests? There are a bunch of events. The 3 main ones that you'll most likely use are the top one, install. So the event gets fired when the service worker is first installed or when it's upgraded. The activate, when the person loads the web page and then connects to your service worker that's been running constantly. And the most common one is this bottom one, fetch. Fetch is the event that will be fired every time that your resources on the web page are being requested by the browser. And you get to then intercept them and change them. There are, of course, you've got a local cache that you can access inside of the service worker that you can use to, that's different than the browser's main cache, and you can use this to build up your application. Different browsers have different limits. Chrome has a much larger limit, whereas Safari only has 50 megabytes available. But this allows you to put stuff into this cache that the browser web page is not requested, and have it ready so that maybe later on you can make a request for it and do a match. So there's a lot of things that we can do with service workers. Now there's a lot of great web content out there. I encourage you to take a look at it and think of it as we can do a lot of the things that we've wanted to do to improve the web, but perhaps we can't reorganize our whole website. Well, we can perhaps deploy a service worker as a safety net to do some of this work. Or in more advanced uses, we can start to replace some of the functionality with service workers so that we can do things like progressive image delivery, bundle splitting, and prefetching. So let me share with you back to this problem that we had about this 30 megabyte web page from Disney. Disney, sometimes it makes me hurt. 30 megabytes. So I'm going to go register my service worker, and then I'm going to add a fetch event. So I want to intercept all requests coming through, and I'm going to filter so to make sure that I'm only doing this on image requests. So I'm looking at the event.request. The request object gives me all the details the browser is going to look at, and looking at the destination. The destination is on the web page, and is it an image? Is it a CSS? Is it a video? And I'm going to take a look at the URL, and then I'm going to be able to change where the browser actually goes. So my event.respondWith. And in my respond with, I'm creating a new fetch. Now, if you aren't familiar, fetch is the same thing as AJAX of the old days. Anytime that you want to make a browser request, that in JavaScript code, you used to call it AJAX or XHR. Now the formal spec is called fetch, and it's a promise-based event system. So you respond with a new fetch. Now, in this example here, I just took the URL from the request and sent it back in a new fetch object. So I really didn't do anything of interest. So I wanted to make my images and video faster. So yeah, I'm going to use my faster URL. Okay, what does that really do? What does that faster URL really do? Let's talk about service workers for image and video performance. So I've got a demo site, and I'm going to give you the links later on. I wasn't confident about the experience here, so I've put in the demo links, and I've got some screenshots for the demo. There's also another irony here, is that here's the web page loaded, and you see this nice image here, and you see that at the bottom, this image was 247 kilobytes. Now, what if I was on a stressful network environment? What if I was on cellular? And of course, this is where the irony is, like, I can't demo being on cellular while also presenting over the internet. So here we go. This is the page before. And I'm going to reload this page. And you'll notice at the bottom, we took that image and we brought it down to 10 kilobytes with my service worker. How did I do this? Notice at the top, I'm using Chrome's developer tools. I changed to slow 3G. Now it's in the top right-hand corner. You can change the different performance characteristics, emulate browsers, emulate different devices, in this case, emulate different network environments. So just by changing to slow 3G, I was able to reduce the bytes that were requested by the browser. That's amazing. How did I do this? Well, it's actually really simple. All I did in my service worker is I took that image and added the W320. This W320 changed the dimensions of that image. And so why am I doing this? I'll breeze through this really quickly here. The main reason that we're doing this is because I've done a number of studies, and I'll be sharing some more studies very shortly. The size of your images impacts the size of the download. This seems obvious, so I did a number of studies looking at the packet retry count, and you can see that if I move from 1,000 pixels down to 300 pixels, I've saved a ton of bytes. And that's exactly what we did here. We just changed the resize down to 300 bytes. There's a second impact, which is as you change the image, the number of bytes that are sent across is one thing, but the browser also has to inflate that into memory, into the browser. So every pixel that you have to draw has to be inflated with 4 bits, red, green, blue, and alpha. And those multiply out every time. So this image, it's 1280, now turns into 2.5 megabytes. And that 2.5 megabytes multiplied with all the other images takes a lot of extra memory. So by shrinking it down, you've actually saved the browser a ton of memory. Okay, I see my time is up, and I believe that we started a tad late, so I'll just give you one quick couple things here. How am I doing this? Well, I'm looking at the save data header, the connection type, and even the device memory. I can do this by looking at the browser and see what the browser's environment is. And that is what I was triggering on to change the characteristics of the image. And these are standard APIs. And unfortunately, if you want to take a look at more, you can turn on save data yourself. And I'm going to skip right to the end here. There is some other goodies, but you can take a look at these demos yourself, basically where we can resize based on the dimensions, based on the network environment, but also we can do some clever things like progressive demos. And these have been great results for many other companies looking at service workers and progressive web apps. And this is a great way to improve the user experience, not just using service workers for offline caching, but also for reducing the number of pixels, the amount of memory that's being used on the user's device, and also then saving bytes substantially. So I thank you very much for your time. I realize that we're out and there's a lot of great things I want to share. So thank you, and take a look at these slides later on. You can get some more of the demos. I'm Colin. Thank you.
Thank you, Colin. So we have some questions. What's questions? This talk was about performance. So there should be questions. I mean, you registered for Jump and the page was loading for 5 minutes. Come on. There should be questions. No questions?
Well, one thing, if there's no questions, I want to share one little tidbit, which I was hoping to share as well. I want to do a little bit of an announcement here, because one of the challenges that you have is, hey, the save data, who's using save data on their data saver mode on their browser? So I see a few hands. Unfortunately, it's only used around 3% of the time. It's not used as widely as we expected. And a lot of times, 20% of the time, the users on cellular are actually laptops tethering. So there's a new API we're going to announce here. I'm giving you a sneak preview here, which is a Cloudinary Net Info API that you can call in any browser, in any app, that will give you details about the user, about the performance of their network connection, so that you can make some decisions. So expect to hear some announcements about this coming up.
Hey, Colin, I have a question.
Yeah.
So you talked about service workers and improving performance. I'm a very vibrant user of Opera Mini. How do I actually, or is it possible for me to use service workers to build for applications that run on Opera Mini?
Yeah, so Opera Mini, I'll just go back to our table up here. Opera Mini, unfortunately, is a proxy browser, or most part is a proxy browser, and that means that a lot of the work is done on the server side. Now, there are different conditions, Mario. So Opera Mini is unfortunately, because it's doing work on server side, then it's not bringing that content. Now, there's some talks about how do we address this? How do we bring the experience to Opera Mini users? And the objective here is to basically create a consistent experience across all users, those that have more or less JavaScript capabilities. So stay tuned is the answer there. Right on. Any other questions, thoughts? All right. I realize it's just before lunch. I do appreciate your time today.
All right.
And if you've got any other questions, feel free to hit me up on Twitter.
Thank you very much, Colin. Let's give him a round of applause. All right, so just before a break, I mean, we're going to have a break soon because I'm sure you guys are tired of sitting. Now, the first speaker for today talked about building Node.js APIs using serverless and Azure. So the next speaker right now will be talking about serverless functions and Vue.js. How many of you use Vue.js here? Come on, I thought you guys were using React just 5 minutes ago. What's going on here? All right. Serverless functions and Vue.js. And the speaker for that session is the awesome Sarah Drasner. Sarah Drasner is a senior cloud developer advocate at Microsoft. She's a writer at CSS Tricks. She's a core contributor to Vue.js. And she's a very awesome human being. So thank you, Sarah, for gracing this occasion. Over to you.
Thank you so much. Can you hear me?
Yes.
Excellent. I'm actually, you know, I speak at a lot of conferences, but this is the most excited I've ever been to speak at a conference.
Woo!
I'm just so thrilled to be with you all today, and hopefully next year I will be with you in person. So, okay, let's go on. Serverless function, we don't have a lot of time, so serverless functions and Vue.js. So I can't see you all, so I'm gonna do a little shout out. How many of you can predict the future? Are there any Bitcoin millionaires in the house, or like early Apple investors, maybe? No? Yeah, I'm not either, okay. So, okay, what for the rest of us, what does it look like when you finally get to launch an app and it's really successful? Well, after you jump around in formalware and everyone's super excited, in the best case scenario that your app does super well, you immediately have to scale your server. And I think we'd all like to think we look something like this in that process, like we've got a dope hoodie on and like we're so good at programming that our fingers are literally on fire. But we actually probably look a little more like this, like that dope hoodie is actually like our sister's hand-me-down rain jacket. And we're not sure if we can find the Q key. And even when we do, we're not sure if we can exit Vim. Or what about the more likely scenario that you didn't exactly fail, but you just didn't get as many signups out of the gate as you were hoping for? In that case, you're paying for all this server capacity that you're not even using, and you're out of cash, and John Travolta shows up in your wallet, and that's really hard to explain to like the VPs at your office. And you could scale down, but like what if things kick up again and then you got to scale your server again? Scaling's a bit of a drag, so that brings us to serverless. It's an actually interesting thing with the most clickbaity title. I mean, the first thing that anyone's going to tell you about serverless is that, yeah, you know, it still uses servers, which is absolutely true. It does still use servers. But the promise of serverless is to spend less time setting up and maintaining a server. So what we're focusing on today is the part of serverless architecture that boils down to functions that state when this request comes in, run this code. And for this reason, sometimes people refer to them as FAS, or functions as a service. I'm Sarah Drasner, known on Twitter as Sarah Edo, and I work for Microsoft. Yeah. I also am a staff writer for CSS Tricks. I'm on the Vue core team, and I've had the absolute pleasure of co-organizing this event with Christian and Brian and William and Prosper and all of the people that you see there. So I'm here today to talk to you about how we integrate these serverless functions with Vue.js applications. So Simona talked about some of the gotchas and some of the things that you might run into and some of the ways that you set up serverless functions. Today, I'm going to talk about some really common use cases and ways that you can work with serverless functions immediately. And because I work for Microsoft, I'm going to show you some pieces that are using Azure, but you can use it with all different kinds of cloud functions. You can use it with any different kind of service. And everything that I'm showing you today is open source, so you can explore the code. So some of the benefits of serverless include not getting into that situation that we talked about before where you're scaling, according to the business. And here's the interesting part. You pay for only what you use, which is usually a lot less. Like the kind of like secret in the industry is that serverless functions are inappropriately priced. So they're actually priced way lower and priced like, kind of too low to the point where companies aren't even making that much money off of them. But that makes it really good for developers because we're actually using something that's super cheap to run. So serverless functions are, aside from being, scaling along with your needs, are super easy and cheap to work with. They're also really great because you don't have to spend time babysitting them, which we talked about before. And something that I really like about them is that they have the same idea as functional programming, which you break things down into smaller bits. So you can have small reusable functions and you can use them across a variety of applications. So some of the stuff that I'm showing you today, you can just grab my repo and reuse it. And another thing that I quite like about it is that it makes use of the principle of least power, which in programming boils down to choosing the least powerful premise suitable for a given purpose. So, okay, we mentioned before that serverless can mean functions as a service, and there's a lot of as a service kind of things out there. So I thought I would do a quick comparison of what you manage for each of these services so you get an idea of like what's going on. This is an actual SVG animation, and there's a link to the CodePen here, which I'll share later. So if we look at the services and what we manage, we have infrastructure as a service. You can see you manage a lot, platform as a service. And functions as a service, you're managing just what's above the waterline. So functions as a service, you're just managing the application layer. Now, when we usually deploy server-side software, we start with a host instance, and then we deploy the application within the host. But in a serverless paradigm, we remove both and replace it with a vendor fast platform that we're not managing ourselves. So we'll deploy these functions to that platform, and this allows us instead to just focus on the logic, which is written as individual functions. And unlike the earlier host and application model, that function isn't continuously running. It's running on an event. When an event is triggered, the function is executed by the vendor in a container. You might have seen this sticker before. It's quite popular. There's no cloud. It's just someone else's computer. I'll just add to this and say there's no serverless. It's just someone else's fully managed execution environment that I only pay a fraction of a cent for whenever my function is run. All right, so does this mean that we should serverless all the things? No, we shouldn't. Serverless is really good for a few different use cases, some of which we're going to cover today, but it doesn't do well for long-running stuff. So anytime there's a persistent connection, so like WebSockets would be one, multiplayer online games, chat applications, real-time updating social streams, those are not good uses for serverless. Serverless is event-driven. So what is it good for? You can clean data on a cron job. You can take data and use it to create data visualizations. And you can create your own API. We're going to actually create our own API today, so that's kind of fun. We're also going to make an e-commerce site, which is also really fun. So setting up a function is pretty trivial. We get a free account. We go into the portal like this. And we have a lot of things kind of autofill for us as we're going through this demo. So one of the things that I want to point out Oh my God, like it's my first time using Keynote and I really love these transitions, like fire. Okay, anyway, that's not the point. Make sure that you're using the consumption plan. That's the one that will scale based on your usage. So the app service plan, which is the other option here, is you're gonna have to manage it yourself. And if you wanna make sure that it's auto scaling, then definitely work with the consumption plan. So right away, they'll set us up with a test, which I've simplified and modified to include tacos, which is really important. So I'm in the request body, I'm passing in this name, which is delicious tacos, if you can't see it. And consider that like a parameter. So if you're thinking about like functions, this is a parameter that we're passing. And then consider this part inside the index.js as like a piece of our function. So the context.res, we're saying that the body is hello plus what our parameter is, which is delicious tacos. The other thing I want to point out is that we can do something like a context log, and context log is very similar to a console log. So we're going to see that outputted below. So if we run this, you can see that we have this hello delicious tacos, which is exactly what you'd hope and wish for. Basically, we're printing out that string concatenation, concat, you know. And then we also have this yo, 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 which we put in inside of our console log or context log. So, okay, this is really cool and very exciting. You already know how to work with functions. These are just the same old functions that you know and love, except they're executed directly on the server. So it's not actually that many things that you have to learn or learn differently. It's really very familiar and very easy to work with if you're already a JavaScript dev who works with these kind of functions all the time. Okay, so we set up a function. Let's put that knowledge to some use and look at a really nice and probably pretty common use case. So let's set up Vue, Stripe, and serverless to create an e-commerce site. And I think you're gonna be really pleased about how easy this is to set up. So if we go through this, this is a sample Vue application I made, and it's a shop where you can kind of order and buy things, except you can't really because it's not a real shop, but it's all open source again, so you can check it out. There comes a time in any young app's life when it needs to monetize, and there are a number of ways where you can accept money, but in like a number of ways that you can do so. But there's nothing quite as direct as actually literally accepting money. So let's talk about how you can literally accept money from any application that you build. And we don't have the time to go through every piece of this application, so I'm giving you a bird's eye view of all of the structure and how it's all set up. So I'm using Nuxt. Nuxt is a really, really awesome thing. If you don't know about, if you haven't used Vue before, Nuxt is like Next.js in React. It's kind of the Vue version of that. So server-side rendering and routing and things like that. So I'm using Nuxt and Vuex. Vuex is kind of like Redux. So you can see here our general store, which is our Vuex store inside of our app. We have the directory, all of the components. When you're using Nuxt, every single component inside of the pages directory becomes a page. So it sets up routing for you automatically. And you have the serverless function and you have Stripe. The serverless function has a little box next to it because we're going to actually install a dependency along with that. So let's do the lowest hanging fruit first. We're going to set up our Stripe account, which is only just a few clicks. So you create your account. Once you confirm your email, you go to the sidebar on the dashboard, and it'll immediately show you your testing keys, which is really nice. It's all set up for you. So when you visit the Stripe documentation, the code that they will give you to execute on the server expects a few different things. It expects the user email and the amount and the description, and we're going to pass all of these things in. But we're already executing on the server. We don't need Express. So Express is really so that we can communicate with the server, but since we're already on the server, we can just execute things directly, which makes our code so much more simple. How about that? Okay, so let's go through what we do to make this work in a few different chunks. We'll add in our testing Stripe key in the module.exports, and we'll kick off a serverless function in Azure. With other services, this line of code will change. So you can see we're creating the customer with the email token and passing in the amount. And then we'll finish everything up and we'll provide some error logs. And you'll note that I log a lot, and that's so that if anything goes wrong, I can track down exactly what happened and when and where. And then when we go into to execute our function, you can see in the test panel, we'll pass in what we're eventually going to get. So we can see, like, I have some like base parameters here, the Stripe email, the token, the Stripe amount, and you can see all the context logs printing. And now you can see the context logs printing, but we can also go back into the Stripe dashboard and see that those payments went through. So that was really all we needed to set that whole thing up. We're now communicating with Stripe. There's one piece that we didn't have time to cover, and it's how to host our function on GitHub if you want to. And I have a whole article about that, and it's on CSS Tricks, so it details how you would do all of that. But it's not that many steps, so that's really good. So we've got one side done, and now we just connect things between our serverless function and our app. And first we'll talk about that Vuex store and our cart.view page. So this is the view that we're looking at right now. So all of our products are in a big manifest object in our Vuex store. So we're also storing what's in the cart, as well as the information, the products, and the total. So you can see here as I add items, our Vuex store updates. And this is really important because this allows us to look at the Vue DevTools, which is really cool. If you're not familiar with Vue, the React has DevTools, Vue has DevTools, so it allows us to see what's actually in our Vuex store. So here's the shape of what we're going to be building on the cart.view page. First, if there are items in the cart, we'll add our checkout component. Then if the cart is empty, we'll give them the ability to get back to the main page and add items. And finally, if there's a success, we'll let people know it's being processed, and we'll add a success component. So let's look at that first code block. If we have items in our cart, we'll show a cart that reminds people of the items with a thumbnail, the quantity, and its price. And here's what that will look like. So we're getting the total from all of the values in our cart, and we're creating a computed value here. If you're not familiar with computed values in Vue, it's a really, really nice way to cache all of the logic based on the dependencies. So it's super performant. So if you're grabbing anything from the store, or if you're getting a new view into the data that you're using, that computed properties are a really nice way of doing so. So now that we're showing what's in the cart, we've got to build that actual checkout form so that they can purchase what's in there. And you'll note that this is what we eventually have, that cart and a place for your email and credit card. And the easiest way, so if you don't want a lot of things that you have to work with or deal with, is to add to your page a component named Vue Stripe Checkout. So I've linked up the repo here. It's literally a button that will call a Stripe modal like you see here. And it's really easy to implement. But what you noticed is I didn't just make a button that turned into a Stripe modal. I actually made it styled along with the page. So if you need a more customized experience and you need to make it look like it's part of the page, you use a thing called Stripe Elements. So for that kind of customization, it's a little bit more work to implement, but really not that much. So it allows you to get the freedom of handling the form yourself and also do all the testing and things like that. So there's a version called Vue Stripe Elements Plus. That's the version that I would recommend. I worked with a whole bunch of them, and this is really the best quality one. So you can use it with NPM or Yarn. And we're going to go over that cart.view page, and we're going to integrate with the checkout.view component, and that's where we'll use the Stripe elements. So out of the box, Vue Stripe Elements Plus has a few defaults. So a couple of notable things here. You would put your Stripe key on that card component, and this button here has a pay method that's attached to the click event. That pay method is really important, so let's go over that really quickly. In the script in the same component, we have some imports, and you can see at the bottom here that pay method. The create token of this pay method returns a promise, which resolves in an object with a token or an error key. So to configure it to our needs, we're going to need to store some data properties, including whether it was submitted, whether it was completed, the status, and the response. We'll also need to gather a bit of information from our cart.view component, which is the parent. And so we're going to use props for that. If you're familiar with React, this should look very, very familiar. We need the total as well as the success. So, okay, here's what that pay method is going to look like once we've customized it. When someone clicks the form button, it kicks off the pay method. We have that create token promise, but now we've changed submitted to true. We're going to use Axios to post the URL to our serverless function and send the email that we've collected from the form, our token, and the total. And you might be wondering where I got that URL from. In that portal view that we saw before where we saw the serverless function, it's right in the corner there. So it just says get function URL, and that's where you can get the information about where that function lives. So after that's complete, we're going to change the status to success, clear the cart with a mutation in Vuex, and log any errors. So to review, because this is the most important part in that pay method, we use Axios to post our function URL, our function to our function URL. We track whether or not we've submitted the form or not with this.submitted. It sends the email, the token, and the total to our serverless function. If it's successful, it commits to our Vuex store. The mutation clears the cart, and it emits to the parent cart component that the payment was successful. If it errors, it changes the status of failure, logs the error response for help with debugging. So while the function works its magic, we're going to show them a loader that's a few seconds long, and it's going on long enough to draw their attention, which reduces the perceived wait time. So when you're a user, you kind of overestimate passive wait times. You're sitting there and you're like, oh man, this is so boring. I don't even know if this went through. Like, come on now, like what's going on over there? Hello. So if you show them a loader that's a little bit engaging, it feels like it happens for a lot less time. And we really need something like that when we're communicating with the server, because we don't know how long the latency is going to be. In the case of failure, I feel so bad for this cat. Oh my God. We'll let them know that something didn't quite work right, and we'll clear out anything set by the pay method, but not the cart. In the case of success, go ahead, Lennon. We'll show a little successful animation to get the dopamine flowing, wait a minute, and then we'll reset the cart so that they can continue shopping. So here you see the loader, and you also see the success. So this is where we are now. That success component is a component of its own. It's attached to the cart page. And here's what it looks like. I isolated it in a CodePen demo for you if you want to check the code. And we'll create a set timeout event that restarts the cart with a function on the parent, which is emitted from here. Okay, so remember this view, we talked about what we're going to do for each piece and the conditions of the statements. So let's fill out what we did. We created our cart, imported our checkout component, and also tracks a successful payment. If the cart's empty, we let them fill it up by going back to the home page. And if the payment was successful, we show them a success component, restart the cart on a set timeout, clearing out what we have. All right, you did it, party. I mean, actually, in like 7 minutes, you set up an entire application, did all of the serverless parts, configured it with Stripe, and now you can accept payments from anywhere in the world with your application with just a few steps. All of this stuff is open source, so you can use the application itself. You can use the serverless function, so you can kind of dig in, grab that code, and even convert it to any other provider that you're using. So you can get started yourself. There's other pieces that you might want to add, like testing is a big one of them. But aside from that, you kind of have everything ready for you in just 7 minutes. Cool. All right, in the time we have left, let's do one more thing. Let's go over another really common use case. We're going to create our own API for a Vue application with serverless functions. So let's get started. So here's our application. I wanted to make an app where I could explore cocktails. This is the initial version and kind of a simple search functionality, has some random functionality. Soon I'm going to make it so that you input ingredients from your house, and then it gives you any cocktail that you can build. But then I was thinking like, okay, I'm going to give this talk, and maybe not everyone likes drinks or cocktails like me, so I could also make like an ice cream finder. Then I was thinking like, okay, some people are lactose intolerant, and some people have diabetes and things like that, so maybe ice cream isn't that great. Okay, so what if we do a puppy finder? Then I was thinking some people like cats instead of puppies, and some people are allergic to puppies, or like they are scared of dogs. So what we can do is we can make a things we like finder, and then people can just kind of decide what they like on their own. But that's a really complicated UX and really hard to build. So I'm just going to use a cocktail finder for now, but you could really use it for whatever you want. So, okay, the first thing we're going to do is we're going to make our function. You saw this before where we just kind of click on the serverless function app. And then if we go in here, we're going to go into the integrate tab, and I'm changing the root template to some other name. So here I'm going to say hello. I'm going to go into the selected methods and just say get. That's all I want for this API that I'm building. And I'm also going to change the authorization level to anonymous. So to review, in integrate, we gave the root template a name. The authorization level is anonymous. And we allowed HTTP methods, and we selected get. So here's what happens if we go to that, remember how we got the function URL? We get the function URL, and we're querying for the name Taco Face, which is my name, and it returns us with hello Taco Face. So that's it. We now have a fully functioning API. So that's super cool. How about that? Okay, we're gonna set up like more information than that. I mean, that's great if you just need like hello Taco Face, but we probably want a little bit more information than that. So we're gonna talk about how we set that up with something like Cosmos DB. So here's the overall setup. Again, this is bird's eye view. You can see that the app is pretty similar to what we had with the shop. The serverless function this time has no dependencies and is rather small. So we're going to use it to surface the Cosmos DB data. If we go into Cosmos DB, we can add a collection. So I'm going to call it Cocktail Finder. Collection ID is cocktails, and partition key is ID. So here I create a Cosmos DB database, a collection. The documents are each drink, and I'm just showing you 3 here as an example. Really, you can use the terminal to add values. You can also upload like something like a JSON file, whatever kind of data and format you want. So I've added this in manually. One thing to note here is that anything with an underscore is something that Cosmos DB makes, and anything without an underscore is actually like the things that we made. So that's the difference that you're seeing here. So back to our function. We're going to go into the integrate tab, and we're going to select inputs here at the top, and then select Azure Cosmos DB and select that. So something to note here is the way that I'm doing it, all the records are pulled out of Cosmos every time, and that's not always going to be the most efficient path, but it's the simplest. So that's for the purposes of this demo. You might want to use something else in production. So this is what we start off with in our function.json. This is the default that they give us. And here's what we're going to add. So I'm going to, kind of zoom into what we're adding here. One thing that you'll note is the type and the name and the direction and the connection are all provided for us, that it just kind of autofills. But we did fill in the database name, which you saw, which was Cocktail Finder, the collection name, which was Cocktails, and the partition key, which is ID. One thing I want you to note here too is that name that says input document, we're going to use that in the next thing. We're going to use that in our serverless function. So that's what we're going to use here. So this is the default serverless function that it gives you right out of the gate. And here's how we're going to update it. We've got our context.log, we've got our context.res, which we used earlier. And look at the body of this. We have context.bindings.input document. That input document is what I pointed out before. That's how you connect them. So if we go in here and we run this, you can see that inside of our function.json in the sidebar here, this is all where we changed all of those values. So that's where everything lives. In the index.json, we save, we run it, and then you can see as we close this out, all of these things coming through, and that's exactly what we had in Cosmos DB. So you can see that kind of coming through the context.log. And if we use CodePen to make the world's smallest Vue app ever, so we have a new Vue instance. If you're not familiar with Vue, we're creating a Vue instance. In the EL, we're connecting it with the divid app. And then in the created lifecycle method, we're using Axios to post to that function URL, and we're just showing all of the response here. That's everything that we need to make a fully functioning API. So we have success. don't tell this porcupine what's going to happen. This is what I think success should look like. I mean, like, okay, let's talk about this for a second because it's really important. In a non-serverless paradigm, you have to pick something like Express. We have to set up endpoints. We have to give our web server secured access to the database server. You have to deploy it. But we created an API with serverless in a few button clicks and just a few modifications. This is a really big deal. So this is the super fun part where we're using that data to output to the page and make things for our app. So if we're connecting this to Vue, this is what our template would look like. We get all of that information that we just stored in Cosmos DB, and we can output it to the page. We're using v-for loops and things like that. And we're also using the object itself. And that's how we're creating our cocktail finder. So this is what we get. A nice API to traverse and create, and it's useful for people building applications for people who like things, and I like cocktails. On that subject, serverless and Vue allow us to accomplish a lot without a lot of infrastructure. It's so cool how all these technologies can play so well together and allow us to accomplish a variety of tasks so quickly. I hope this gets you going playing with pairing Vue and serverless in the future. I'll be posting in Slack my slides, and there's also GitHub repos that I'll be posting so you can play with all of this code. Thank you so much.
Thank you, Sarah.
I think we don't have too much time, but I can take a couple of questions if people want.
Yeah, any questions? Oh, okay, we have a number of questions.
Hi, thank you, Sarah. I'm Olabode Abeshin. My first question is, can I write my entire web application as serverless? So microservices here and there, microservices. And then also, how do you handle authentication?
Great questions. Okay, you can't write the entire application as serverless functions because you need stuff on the client, which is where Vue comes in, right? Vue does a really good job of giving you the view layer. React does that too. Angular is more of an MVC, but you could just use it as a V if you want. But serverless and Vue communicate really well together, basically by that relationship that we're creating with Axios. So when we see that serverless function, anything communicating on the server can be done with serverless functions, and anything done on the client is done with Vue. So you can almost do the entire application with serverless functions, but really what you want is to be pairing something on the server and something on the client. And what's nice about serverless is that you're still writing the same type of functions. It's kind of like the methods that you would use inside of the Vue application. So yeah, pretty close. Okay. Authentication, I think Auth0 is a really, really great way to provide authentication for a Vue application. And actually Christian, who's there on premises, has written a whole bunch of Scotch.io articles on how to create Auth0 authentication with Vue. And I think that that's a really nice kind of paradigm to work with.
Okay,
so
thank you. So I'm using a third party for my authentication, right?
I'm sorry?
In that case, I'll be using a third party for authentication.
Yeah, third party authentication.
Okay, then how do you handle latency? Because if the server if it's not working, if it's not online and I'm not paying for it, I only pay for it when it's working, then how do you handle the latency in performance?
Actually, that's a really great question because serverless functions do sometimes have this thing called cold start, which can take a little while. So it's basically one of those things where if you write it yourself on the client, or if you write it yourself inside a server but not a serverless paradigm, it might be faster for you. So serverless might not be the best use case for Auth0. It's not always the best use case, right? We talked a little bit about persistent connections. Anything where you're going to have to really focus on latency, serverless is cheap, but it might not be best for that. So that's a really great question, and I think that probably serverless might not be the best paradigm for that. Anything else? Should we move on?
Okay. Hi, Sarah. Thanks for the talk and the effort towards the conference. So my question is related to what the earlier person asked around cold start times. What other metrics will one assess cloud function service providers by? Like for regular web hosts, we're used to SSDs, virtual CPUs, and RAM to estimate performance. But for cloud functions, what should one look at in terms of to assess performance?
Yeah, that's a great question. One of them is scale, right? So one of them is to see how quickly things can scale. A little while ago, for functions for Azure and AWS, they did like someone outside did a comparative analysis of all of those. And they found a bunch of leaks basically among all of the cloud providers. Ours in Azure were very bad. But really what ended up happening was that Azure started to just throw money at the problem and burst scale immediately. So those scale issues should be course corrected. But that's one thing I would measure, is to see how fast things end up going and bursting out when you need scale. Another thing that you might want to check is when the function's not hot. And what I mean by that is if you haven't run a function in a little while, that's when you're going to get those cold start times. One way that people have been using in the industry to kind of trick this thing, and it's an industry-wide problem, it's on every service provider you're going to deal with cold start times. You can have a set timeout function that retriggers the function so that it kind of stays hot. It doesn't always work exactly right. There's one last thing that we're coming out with, and I'm not allowed to say too much about this, so I'm going to try to skirt around what I can say. Azure's going to come out with something that's like a hybrid model, where you pay a little bit more. So serverless functions are super cheap. You pay a little bit more, and then you don't pay for cold start times. So in order to kind of circumvent that, if you want to work with the serverless paradigm, you kind of have to pay for it because it is dedicating pieces of the server to that task. Really, usually with serverless functions, we're using leftover capacity, and that's why it's so cheap. So this would move away from that paradigm a little bit, but it wouldn't be as expensive as running on a traditional server, like just hosting on MongoDB or something like that. So that hybrid model, I think we're going to be calling supreme functions or like deluxe functions or like some sort of sandwich kind of analogy. So look out for that. I think they're going to be announcing it in a couple of months, but they said that I can kind of talk about it a little. So I think that that's something that you should check out when it comes out.
One last one is, can functions share some sort of non-persistent storage between requests, across requests?
Non-persistent storage across?
Yes.
Not really. Serverless functions don't hold data. They're really just functions. So you can think about them as the same kind of functions that you're dealing with on the client. Like a function on the client isn't really holding resources either necessarily, maybe small bits, but it's not going to be that performant to hold a lot of data, right? Like in a normal function, that's not where you would host like all of the information for your store. Like, you'd put that in Redux or Vuex or something like that, or store it in some sort of other object. So it works the same way. So you'd really want to hold your data somewhere else, and then the function kind of coordinates that. And there are even things like durable functions, which allow you to coordinate many different functions at different times. So if you do need to talk to a server and then do something else and keep those bits kind of small, those durable functions will allow you to keep those things orchestrated. Great questions, yeah.
Yeah, thank you. So my question is, how does testing work with serverless functions?
That's a great question. So in Simona's talk that was earlier today, she talked about local debugging, and that is probably the most important thing that you're going to need to know for testing serverless functions. So again, like you could write a function, like a test inside of the portal, but you probably wouldn't want to do that. What you probably want to do is host it locally, bring it into GitHub. I have that CSS Tricks article that shows how you bring it into GitHub. Simona's talk earlier talked about how you would do local debugging, especially if you're using VS Code, you can use that extension that allows you to do local debugging. And then you can bring in some dependencies that help you with testing. And it's kind of similar to a process of testing on the client as well. But you do need to be working locally, I think, to really make that work well.
Thank you.
Thanks.
Thank you, Sarah. Thank you for that awesome presentation.
Thank you so much for having me.
All right, guys. So right now we're taking a break, but then you don't have to move. Now the reason why is because there is food. And there are no functions involved. So if you move around, the food might be deployed somewhere else. So let's just sit where we are right now. I mean, you can make friends, but don't move around too much so that the folks serving the food can know what you're doing, all right? So we're going to have a break for like 1 hour, 60 minutes. That's enough time to eat, chat up, deploy the features that your boss asked you to, work on some testing,